Hey guys, welcome back. So we're gonna have episode 2, which is the scary diamond programming thingy that I have ranted all summer over. Sorry about that. That was just immaturity over COVID. But really, diamond programming is very important for interview problems, and they can be one of the hardest. Let's get down to business. Oh yeah, before you continue, make sure to subscribe to my channel, Jason Liu, and hashtag diamond programming. So yeah, this problem is actually pretty fun. Have you guys heard of Smosh Games? It's a really cool gaming channel that's popular with teenagers and young adults. They used to play a summer games called Hangman. Now the game of Hangman is pretty simple, as I'll demonstrate in the next segment. Ordinarily, Hangman is played like as the following. You have a bunch of spaces, you have a stick or a post, you have this, right? And the set of letters you can guess for is from the grammar of A to Z, or in good old Bacchus now form, A to Z plus. That's just regex stuff that you can learn on your own. So let's, for example, say, let's guess this word from Hangman. So probability-wise, you can see already why we're going to use DP, right? Because this thing, if you use brute force, you go for 26, choose 4, which is a lot, times 26, choose 4, times 26, choose 4, times 26, choose 4. And that is almost infinity. That's like just too much. So you can already see using brute force, guessing every 26 letters for just 4 letters is just way too much. This is why you will use dynamic programming, to turn them into a subproblem for optimal solving. So we have a subproblem to solve in the DP. So now I will show you guys quickly what the DP algorithm, or in the Christian terms, the commandments of DP would become. So dynamic programming has just 5 commandments. Here are the commandments of dynamic programming. Make sure you memorize them, because either in interview or university or LeetCode, you do not have any of these steps, it's GG for you. Sorry to be harsh, but dynamic programming is graded pretty much as a pass-fail basis. Step number 1. Is to have a subproblem. Which means the smallest example that defines the DP. Oh, by the way, these are the commandments of DP. Like, they are legit must-haves. Number 2 is thou shalt have base cases, which means you should have base case in your recursion. Number 3 is thou shalt not forget runtime in both recursion and final. And number 4 is thou shalt not forget, or thou shalt honor thy number subproblem, which means you should say the subproblem and the number of how many subproblems they are. And finally, number 5, very important, people often forget, it's like the part of the lobster that you do not eat, but it's still good for you, which I speak from personal experience before this year, is that back in like BU, we used to eat lobsters, and we used to have people who just eat the lobster like good enough, but not to the point where we actually can, like, you know, really enjoy all of the lobster. So do not forget the last piece of this so-called lobster we're eating, which is thou shalt remember final solution. And these are the commandments of dynamic programming. No matter what university or leak code problem or interview challenge, you'll have to have these exact steps. Subproblem, base cases and recursion, runtime, number subproblems, and then final solution. By the way, to really flex on the intensity, you normally would get a 0 on a examination, or you would not pass the interview if you do not have these type problems. I learned the hard way that why you have to keep these things in your mind. So now, with the DP fear mongering over and the scare tactics of the thing over, let me show you how simple it could be to solve a DP problem using the Smosh Hangman. So regarding to the Smosh DP problem, let's start off with our subproblem. So subproblem goes as the following. We have aptly called our what we call Bellman equation, which is called Smosh. Oh, by the way, Smosh Games did not actually sponsor me say this. This is just my personal example of how DP works with a fun, cute example. This is called our Bellman equation. So Smosh has three main parameters, R, C, and W. R is the number of letters guessed. C is the number of Hangman pieces drawn. So definitely don't let C equals N, which is the total number of N pieces being drawn for Hangman. And then W is of course the delimiter to guess the word. So now I'll show you how to explain all this in English terms so people can understand what I'm trying to say outside of CS terms. So yeah, the subproblem is defined as English as the follows. So the goal of Hangman, of course, is to guess as many letters as you want before guessing the word, right? So why is that not a good subproblem? So let's just say for first attempt / false start / newbie start that we try the following. It's just the max number of letters guessed before revealing word W. Well, two reasons why this is called an incomplete subproblem. One, you're forgetting completely the parameter C, which is important. Do not forget any parameters when you're doing dynamic programming. And two, you have no idea where to start. This is just, as they say in millennial language, this does not slap, you know, does not compile. It's not Gucci enough. It's not good enough. And interviewers also say that as well, saying this is incomplete solution for dynamic programming. I personally have tried this on a leak code solution, and let me tell you, it is actually tough enough that you can't even get through the first part of the test cases if you don't have the entire subproblem written. So how do you write a subproblem properly? Well, let me show you. First of all, you have to know what you're trying to do, a max, a min for the DP. So we're obviously doing max in this case. So we're writing max number of letters used, which is R. Which would denote as R. And how do we make sure that we don't have the game over where we have this case where you draw the entire Hangman? You don't want that? Well, you have to minimize something, right? So we do the min with the min of number of Hangman drawn. Which is C. And then finally, we say with the delimiter of W word guessed, and then to end the subproblem, we have to say from what interval or what position. And usually in a game of Hangman, we just keep guessing until the hangman gets drawn or we guess the words. Same thing with the Smosh Hangman game as well. I saw Joven and Mari basically guessing until somebody gets splashed. So we do the same thing. And then we basically say at each turn, including the ARF turn, which means until we have guessed the maximum number of letters we can guess, that is how many times we have the subproblem. So, to speak in non-CS plain English, the subproblem is we're trying to maximize the number of letters used, minimize the number of hangman pieces drawn, with the delimiter of W for each word guessed at each turn R, which means basically trying to keep on guessing until we draw the hangman, or we guess the word, or we guess the word through all the letters used. Sounds complicated, right? Even your little childhood game Hangman can get complicated. Well, we'll eventually show you how to use recursion or Bellman equation to simplify all this jargon. So onto recursion. Recursion is basically a fancy CS term for saying solving the same problem over and over and over again, but going backwards, which is exactly what DP is equal to. Like Sarah Kierkegaard said, life can only be understood forwards if you move backwards. Thank you, Professor Viola. So, recursion is the following. We have the good old Smosh, R, C, and W. And we're gonna draw a little bit big here. So what's the first thing we need to think about? Let's just say Joven and Mari just wanna, play games and don't play the game at all. Basically like, the ideology that if the game is rigged against you, just don't play at all. So they're gonna go for 0, right? So they go for 0 if they don't guess anything and they don't draw anything, and basically they don't play the game at all. That is one legitimate, weird base case. The second one would be really boring. The word is A or O, just one letter, right? That's the second case. If the word is just legitimately a boring, one letter, whatever. And then finally, this is where it gets interesting. This is where DP also gets fairly challenging, to know where to max and where to min. So for the Smosh game, obviously we're trying to maximize the number of letters we are using by minning the pieces of Hangman being drawn. So far, in these two cases, we haven't drawn any Hangman pieces, so we're obviously gonna max. And then why I choose 1 through I through 27, not 26, is because we're including the space as a potential letter. Including the space as a letter. Normally Hangman doesn't do that, but just to make things a little bit easier, we're going to include the space. So now we continue recursion with the min case. So the min case is the following. We have min of essentially 3 things, from 1 to I to 27 of the following. Let's say, for example, we just want to randomly guess the letters, and that is it, right? So in that case, we just keep on using up the letters and using up everything until we have reached the ith case of where the Hangman has been drawn, or more reasonably, something goes on and we suddenly have to guess a word. So as a small example, 1, 2, 3. We have a 3-letter word, and when it gets the word, I don't know, cat. In this case, we have the base case of not 0, not 1. So those base cases are no longer applicable. So you have to use recursive case. So this sort of gets into the concept of a subsequence when you think about the recursive case. Let me first write down the recursion. Then I'll explain case by case what it means. DP is like driving a car. You're given the driver's manual, you're given all the stuff, it's just not writing the stuff for the road test and trying to make sure it compiles. Computer science is really just preparing for a road test constantly with programming when it comes to dynamic programming. That was the attitude I brought to even understand DP at this level. So take it from me. You treat it as your high school road test and just keep on practicing, keep on, soon essential, like practice makes perfect. You'll get there. So let me write down the very seemingly complicated, but rather intuitively easy subproblem. And that is not a good way to write it. I am sorry. I'll write a little bit smaller. There we go, much better. So this this recursive case is very similar to that we call edit distance, actually. Edit distance, which is a very famous bioinformatic example of dynamic programming. Check it out. I'll actually show you in the comments below what I mean by edit distance once I finish making the video and finish the DP. And since this is Algos in 10, not Algos in 20, I'm going to now quickly go through the rest of the solution. So for Smosh, R minus I, C minus I, W, this is basically saying that you've guessed up to I letters, and you've also dropped up to I amount of letters for the Hangman, and for some reason, W has not been used. Then for the other one is you basically guessed up to R letters, but you draw the C minus I times and you had W, which means you basically did not guess the word. And then finally, you guessed the word and you got the word. So to make it in layman terms with a different marker, so case one is you basically do not guess the word. 2 is you got the word wrong. And 3 is you did guess the word. And that is basically it for the recursion. Once you got that out of the way, the rest of the problem is basically analysis with runtime, which we've done already for the Jack Sparrow divide and conquer. And you also could try a lot with CLRS and LeetCode. So the first thing we're going to do is the number of subproblems. That is pretty trivial. How many times do you guess in an n length word for Hangman? O of n. N is the length of word. We're including spaces in this case. Now time for recursion is a bit trickier. So if we go back to the recursion we had earlier, we noticed that this is saying up to 27 characters, essentially, guessing the word in the dynamic Hangman. And also, according to the Smosh rules, you cannot double guess. So we're basically uniquely guessing the letters based on either vowels or consonants, A, E, I, O, U, or the consonants, which is the subset outside of A, E, I, O, U. Sometimes Y is a plus minus 1 case. We're going to just let it yeet. Let it slide for now. So time for recursion is O of R, where R is the letters guessed, actually. Counterintuitive, right? It's like you try to basically parallel park right now in Boston, and for some reason your parallel park has the car going the other way, which means you end up doing a 3-point turn. So the thing about DP is that you don't use the right parameters, you're going to end up doing the complete opposite or even the wrong solution of what you intended to do. So this is why dynamic programming can get hard, is that it's very hard for you to keep track of what's actually been asked and what you're trying to do, that you're trying to solve in a problem. So always have some sort of English, even if it's just straight up like phrase or description, is good enough for the interviews. And then finally, we have the 2 remaining cases. The final solution, which is just straight up the time of recursion times the number subproblem. And this thing turns out to be a quadratic solution, which is pretty nice. Like, Hangman as quadratic is pretty decent. Sounds like Smosh actually is teaching me how to be more efficient, despite gaming and Jova and all that stuff, you know? And then finally, we have the final solution, which is the O max of the following: I smosh 1, n, w, where n is of course, the total number of letters for the word, 1 is the first letter you guess, and w is the word that you guess if you find the solution for Hangman. And this is actually final runtime, so DP can get tricky. It's like, you know, it's like driving. It can get tricky. So that's our solution for dynamic programming for Smosh, which is fantastic. It's NR, which means generally for DP solutions, if you have quadratic or cubic solutions, even at that, you're generally you're in a safe ballpark. The interviewer will not think you're taking too long for the algorithm, or it's too brute force, or it's anything bad. But there is one way to make it better. I'm not going to show you how in this video. This is a more of an advanced topic. But there are two forms of DP that you should know. The bottom up, which is the one we are doing today, recursion. And there's something called the top down DP. Whoops, I switched it up. Top down is actually recursion. Bottom up is iterative. So we were doing the top down DP today. Yes, that's the two differences. In addition, there's something called memoization as well, which means basically put it all in an array. So the memoizer thing means you basically put it in an array. Memoization will become clearer once we solve another problem regarding Fibonacci dynamic programming, which looks easier than this problem, but in reality is actually not, because you could generalize Fibonacci to Fibonacci and n-Nachi. So yes, the TLDR, the takeaway of dynamic programming, is being able to actually get clear in the head. What is a subproblem? What's your recursion, including base cases? What's the number of subproblems, the time per recursion, and the final solution? If you have any questions about DP or have any struggles or grievances with it, please chime in the comments. Thank you very much. It's Algos for 2 with Jason Liu, Algos and 10 for Jason Liu, episode number 2. Make sure to subscribe.